Very good evening, all of you. Dear friends, today we are going to discuss the mathematics class 10th, chapter number first, real numbers. So, we have already defined the real numbers, or simply we can also define those numbers are lies between minus infinitive to plus infinitive. At another way, we can also say that the real numbers is the collection of rational and irrational numbers. So in the second way, but in this chapter we are especially discuss about the Euclid division lemma. This is the simply the statement. We will define this. Now let us suppose that let us let us suppose that there are two positive integers positive positive integers a and b, and now we are supposing the a and b are the two integers. It means that it must be one of them is greater than others. That is, we can say that, or and a is greater b, or b is also, we can also write this, or b is greater a. Simply we can also write this. So there must be exist there there exists there exist there exist two unique unique positive integer positive integer positive integers r and q, satisfying satisfying the condition satisfying the condition r. This is simply suppose we will also define the r means simply r is the previous suppose first letter of the remainder, or q is the quotient, so first letter of the quotient is q. Okay, so we have already defined this, but once again we will also define. Satisfying the condition, the condition is defined as a is equal to b q plus r. Suppose um, r equal to 0 or greater. R, it means that r equal to 0, or present the r is greater than 0. What r is less than the value of v. V means this is the divisor. Suppose here we can also we can write this statement as v is the divisor, and this is the a, and you will get here r. This is the r is remainder, and there is the q is the quotient. Okay, so each terms we can also define here, where a means this is the um, value integers, what it is said to be the dividend. Okay, this is the dividend, and b is simply defined as b means divisor, and r simply as a remainder, and q means quotient. question. Okay, so this is a for a is dividend. It means that divisor b, if a number is divided by another number, so this can be a number which is divisible by divided by b, so b is called the divisor and a is dividend and r is remainder, but q is the quotient. Okay, so let me explain the Euclid division lemma. So this is the Euclid division lemma. Let us suppose that a and b are the two positive integers. A is greater b or b is greater a. There exists the unique two positive integers r and q satisfying the condition a equal to bq plus r. R may be 0 or greater but less than b. So this is the statement is called the Euclid division lemma. So dear students, you must remember this statement, because the CBSE question paper always ask the write the statement of the Euclid division lemma. So you can also write this. But widely the application, what is the application of the Euclid division lemma? So we will discuss the application when we are just finding the SCF of the two numbers or two or more numbers, then you can utilize the Euclid division lemma. Okay, so first suppose application of EDL, Euclid division lemma. Mostly it is utilized in the finding the SCF of the two numbers. Now let us suppose that let a is equal to 18 and v is equal to 12. There are the two positive integers. There must be the exist the two positive integers. What here we are observing, a is greater v. In this case, a is greater b, a is greater v. Okay, it means that is 18 is greater 12. Okay, so must it means that the 18 is dividend and 12 is divisor. Okay, first so we will define this. And suppose 18 is divided by 12. Okay, so there must be divide the one times, so you will divide this 12 1 12. So now subtract this one, you will get the 6 here, and in this case the remainder is 6, and remainder is working as a divisor and the divisor will be dividend. Okay, so this will be the 12 and it will divided by 2, so this will 12, and now the again subtraction remainder is 0. So this process is repeated until you are not getting the remainder 0. So when you will get the remainder 0, then this process is stop. Okay, so now in this case we will utilize find the HCF of 18 and 12. Application of the EDL, Euclid division lemma, we will find the HCF of the two numbers, positive integers. Okay, so find the HCF, highest common factor, HCF of 18 and 12. Okay, so utilize the, we here use the Euclid division lemma. So we use the EDL. Okay, Euclid division lemma. So first step number first is defined step number first. So we can also write this one, the 18 is equal to this will 12 is the divisor and 1 plus 6. Okay, 6 is the remainder, and now step number second, step number second, this is, and the next step, the divisor will be the dividend and remainder working as a divisor. Okay, so 12 is equal to, this will be 6 across 2 and divided by 2 times, and you will get the remainder 0. Okay, so this is here the last step, step number 2. Here the divisor is the 6, so 6 will be and remainder is 0. If in this step, in this step remainder are equal to 0. Okay, so repeat this process until you are not getting the 0. If the remainder is 0, then they stop the process. Okay, so remainder, and in this case, in the last step, there is this process. Okay, remainder in this line, in this step, the remainder is 0, so the divisor is 6, is the HCF of the two positive integers. So the HCF, so the HCF, highest common factor of 18, 12 is equal to 6. Okay, so widely utilization of the EDL is to finding the HCF of the two or more positive integers. Okay, so I hope that this video is very useful for you. Thank you so much.